Hey guys, I am Shanol. I am a software architect in a USA company. In this lesson, we will create a Spring Boot project with using MySQL database. Our project will be a user management system. First of all, we will create our project, then we will test with using Postman, and finally we will push it to GitHub repository. And we will implement all code step by step. Let's start. In this section, we will create our Spring Boot application and we will import it to IntelliJ. To create a Spring project, the best way is using Spring.io. We can reach Spring.io from start.spring.io. First of all, we shall choose our project type. Our project will be a Gradle project. But if you want to go with Maven, you can choose it also. We will use Gradle because Gradle has easy configuration and better performance than Maven. Secondly, we will choose our language. Our language will be Java. Our Spring Boot version will be a stable current version. Our group name will be com.sha. Our artifact name will be Spring Boot MySQL daemon. Last thing about project metadata is to choose the Java version. We will go on with Java 11. Okay, that's all about metadata. Let's choose our dependencies. First one is web, because we will use model view controller structure on our service. Second one is Java Persistence API, because we will use object relational mapping. The other one is REST repositories, because we will use REST API services. The other one is Lombok library, because we want to write clean code. We don't want to describe getters, setters each time. The last one is MySQL driver, because we will use it for database operations. Okay, that's all about dependencies. Now we can generate it. We are almost ready to start programming. Now we will import it to IntelliJ. In this course, we will go on with IntelliJ, but if you want, you can go on with Eclipse or other frameworks. After importing it to IntelliJ to enable Lombok operations on IntelliJ, we should enable annotation processing from preferences. Okay, now we are ready to start coding. By the way, if we run our project on this step, we will get errors about database configuration. This is so normal because we didn't configure it yet. We will handle it in the next sections. In this section, we will implement application properties for our server side. You know that Spring has default configurations, so in this section, we will customize these configurations.
We will use MySQL in our project. You know that MySQL works with databases, so Spring should know database name and user credentials. So we can easily set them with using spring.datasource.url. There are important things in here. If you notice it, we have like use Unicode, use legacy datetime code, server time zone in our data source URL. This means we will use UTC server time zone, not default time zone. So with this thing, we can escape time zone errors. The other thing is create database if not exist. So this will create our database automatically on our host. The other thing is allow public key retrieval properties. If the user account uses SHA-256 password authentication, the password must be protected during transmission. With setting allow public key retrieval to true, you can get your connection with your public key. Our other property is spring.datasource.username and password and driver. These credentials should be according to your MySQL authentication. In my case, my MySQL username is admin and my password is 1234. So you should change it according to yours. In our project, we will use Hibernate DDL change set auto configuration. To set it, we will use spring.gpa.hibernate.ddl auto equals update. DDL auto property can be create, update, validate or none. Create means delete and create database from beginning for each time. Update means just implement changes. Validate means just validate database according to Hibernate entities. Okay, this configuration will be enough for us for the beginning.
In this section, we will create our model class for user.
To do it, first of all, let's create a new package under our main package. Our package name will be model. Under the model package, we will create a user class. User class will have a database table relation. So our table name will be user. User class will be a Java persistence entity class. We will have an ID field and ID field will be the primary key and it will be auto increment generated value. Identity means Hibernate relies on an auto incremented database column to generate the primary key. Another field is name. Other field is username. Username will be a unique value. Our last field is CRUD time. This field will be a local date time. To getter, setter, equals and hashcode methods, we will use Lombok data annotation. Lombok data annotation will handle getter, setter, equals and hashcode methods. Okay, we have just created our model class.
In this section, we will create our repository class for our user model class.
To do it, first of all, let's create a new package under our main package. Our package name will be repository. Under the repository package, we will create a user repository interface. User repository will extend GPA repository. GPA repository is an abstract class implemented by Spring GPA repository. With GPA repository, Spring will handle basic CRUD database operations automatically, like save, update, find by ID, etc. GPA repository has two generic parameters. First parameter is for the model class. The second parameter is for the ID class of the model class. So our model class will be user and our ID class will be long. Okay, now we can create queries in user repository. Our query will be finding users according to username. We know that username is a field of user table. So in GPA repository, we can find it by using find by plus field name. So in our case, we can find it like find by username and our parameter will be username. Okay, that's all about user repository implementation.
In this section, we will create our user service class. In Spring, there is a cycle in model view controller structure. First of all, describe model classes, later call model classes from services, finally call services from controllers, and controllers will return model classes. So, in the previous section, we described our user repository. In this section, we will call it from service. To do it, first of all, we will create a service class.
To do it, first of all, we will create a service class. First of all, let's create a new package under our main package. Our package name will be service. Under the service package, we will create a user service interface. And under service package, we will create a user service implementation class. And this user service will implement iUser service. To describe user service as a service class, we will add service annotation to it. Later, we will call user repository. To dependency injection, we can use auto-wired in Spring. Okay, now we can create our methods. Our first method will be save user. To save user, after setting default values of user, we can call user repository.save method. Our second method will be find by username. We can directly call it from user repository. Our last method will be find all users. We can directly call it from user repository. Okay, that's all about user service implementation.
In this section, we will create a user controller. Like we said in previous section, in Spring there is a cycle in model wave controller structure. First of all, describe model classes, later call model classes from services, finally call services from controllers, and controllers will return model classes. So we described our services in previous sections. In this section, we will call them from the controller and we will map our REST API requests. To do it, first of all, we will create a controller class.
First of all, let's create a new package under our main package. Our package name will be controller. Under the controller package, we will create a user controller class. To describe user controller as a REST controller class, we will add REST controller annotation to it. Each method path for user controller will start with API user. Later, we will call user service. The dependency injection we can use auto-wired in Spring. Okay, now we can create our API methods. Our first method will be save user. In the REST controller, we will define every method with response entity capsulation. Response entity is a capsulation that contains HTTP header, HTTP status, and response body. For our save user method, we will reach form data of request with request body annotation. And request body can be reached with post mapping requests. So our mapping request method will be post mapping. And the API path will be like the default path of class. So it is API user. In the save user method, username should be unique for each user. So we should check whether the username exists or not in the save user method. If the username already exists, we will return HTTP status as conflict. And finally, we call our user save method from user service and return created HTTP status. Okay, that's all about the save user method. Our second method will be find all users. Our find all users method will be a get request mapping. And the API path will be the same with class path like API user. And finally, we will call our find all users method from user service and return with OK HTTP status. Okay, that's all about user controller implementation.
In this section, we will test our endpoints with using Postman. First of all, we will start our application from our main class. In here, we have a bug about application properties, data source user, data source. It will be data source actually. Let's fix it first of all. Okay, then we can run our main class. Then we will open Postman if it is not yet. Then we will firstly test the save user endpoint. Our endpoint is a post request and the endpoint is API user. Now we can create our request body. Content type will be JSON. Okay, now we can call it. Our second endpoint is get all users. It is a get request and the endpoint is API user. Okay, now we can call it. Okay, everything looks like working on local. In this section, we will create our GitHub repository and we will send our code to this GitHub repository. To do it, first of all, we will open our GitHub dashboard. Then we will click to create new repository button. Then we will specify our repository name. Our repository name will be Spring Boot MySQL demo. Then we can set access rights. In here we will set it as public, but of course you can go on with private mode. Then we can create it. Actually, GitHub says what we do to import our code here. First of all, we will initialize Git on our project. Then we will add all items to Git. Then we will relate our remote repository with the project. Then we will commit our codes with a commit message. Finally, we will push it to a branch. In IntelliJ, we can do it via command or we can do it via user interface. In here, our Git commands are ready, so we can use these commands from the terminal easily. Init add commit with initial message, then relate our remote repository, finally push codes to our master branch. Okay, now our code is reachable from GitHub as public. That's all.